Good day, students. Welcome to part one of the mixed review for your upcoming exam. We're going to be focusing on exponential growth and decay applications in this clip. Okay, so let's take a look at the first question. It says Linda wants to invest $13,000. She's looking at two possible accounts. Account A is a standard savings account that pays 4.6 annual interest rate compounded continuously. Account B will pay her a fixed amount of 260 every quarter. Part A, Linda can invest the money for 12 years only. Which account would give her the higher return on her investment? How much more would she make by choosing the higher paying account? Alright, so let's develop a model for both scenarios first, and then we're going to then answer the question. Okay? Alright, so let's start with account A. Account A is a compound interest scenario that's compounded continuously. Alright, so for account A, since this is continuous growth as a continuous growth model, we're going to be using the equation y equals a e to the rt. Okay, remember a is the initial amount, and t is the time, and r is the rate. Okay. All right. Another variation of this can also be written as final amount equals the principal times e to the rt. Okay. Any of these formulations will work. Okay. So in this problem, the initial amount is 13,000. The growth rate is 4.6%. To the right, it has 4.6 over 100. So to change this into decimal form, we need to move the decimal point forward twice. Why? Because we have two zeros downstairs here. In order to change 100 into 1, I need to move the decimal point forward twice. So we'll do the same thing on the top. We need to move it twice to make it over 1. So you have to insert a 0 here, a decimal point there. So this becomes 0.046. Okay, and at the time we do not know for now. So for account A, the model is y equals starting amount 13,000 e to the rate 0.046 t. Okay, so this is the model that we're going to be using to predict the amount at any time t for account A. Okay, all right, now for account B, that was a little bit less complicated. It's just a fixed growth rate. Okay, if you think about something growing at a fixed rate, it's going to be a linear model. Okay, so for account B, we're going to be using a typical linear equation to model this. I'm going to use it using the following formulation: y equals at plus b. Okay. All right. So a is going to be the initial amount, and t is the time. And wait, I got it mixed up. B is the initial amount actually. So B is the initial amount in this form. A is basically the growth rate or the slope. Okay, the growth rate. Now another thing we want to note is the time for this growth is every quarter. Okay, so since it's going to be every quarter and t is going to be in years, we're going to have to be multiplying our time by 4. Okay, so our time is going to be times 4 since there are 4 quarters in a year. All right, so we're going to keep that in mind. So time is going to be time times 4. All right. Okay, so the model for account B is going to be y equals the growth rate, which is 260. So since it's per quarter, instead of just t, it's going to be 260 times 4t. Okay, 4 times per year plus the initial amount, which is 13,000. All right, so that yields the model y equals, you can now multiply those two numbers, 260 times 4 is 1040. Y equals 1040t, 1040t plus 1300. Okay, so that's the model for account B. All right, so now let's answer the question. which one will give a higher return after 12 years? So after 12 years, t is going to be 12. Okay? So for part A, let's make it A and B. Part A, set t equal 12. All right? So for account A, the amount we're going to get for account A is going to be y equals 13,000 e to the 0.046. T in this case is going to be 12. All right, put this in parentheses. 0.046 times 12. All right, let's use our calculator to compute what this is. So it's going to be 13,000. Second function ln gives you access to e to the 0.046 times 12, and your answer is $22,577.50. So y equals $22,577.40 approximately. That's for account A. Okay. Now how about account B? Account B is a linear model. What's the amount going to be? So for account B, we're going to plug in t equals 12 into this second model we got right here. So it's going to be y equals 1040 times 12 plus, supposed to be 13,000, plus 13,000. Okay? So let's see what that is. Plug it in our calculators. We have 1040 times 12 plus 13,000. We get 25,480. So y is going to be 25,480. So which one is better? The fixed, is it the fixed rate or the one that's compounded continuously? You can clearly see that account B is higher. So the question says, we should give a higher rate of return. So for the A part, account B will. We'll do what? We'll give her a higher rate. Give her a higher return. Alright, so the question now is, by how much does she get? How much more does she get with account B than she'll get in account A? So she will get, what is she gonna get? The difference, right? So 25,480 minus 22,577.4. That'll give us the amount she's going to get more using account B than account A. Alright, so let's just plug this into our calculators. So we're gonna go answer minus 22,577.40. Answer is $2,902.06. So $2,906 and $902.06. Okay, 902.6. So this is how much more she'll get from account B. She'll get $2,902.06 more by choosing account B. Okay. All right. Now let's take a look at question number two. Part 2 is kind of related, the same question, but now in this case we have 24 years. Okay. Same question, but for 24 years, which would give her a higher rate of return. Okay. So let's look at account A again. For account A, remember for 24 years, T is going to be 24. Okay. So for account A, well, how much is she going to get using account A, the one with that's compounded continuously? It's going to be y equals, using the model that we got before, 13,000 e to the RT, which is 0.046. In this case, T is 24. Okay, so we're going to plug this into our calculators, and that's going to give us a result. So let's go ahead and plug it in. 13,000 e to the 0.046 times 24 Answer is 39,210, 3921069. 3921069. Okay? Alright, how about account B, the fixed rate, the fixed growth amount? So for that one, we're going to use the second model we got, y equals 10, 40, in this case t is 24 times 24 plus the initial amount, which is 13,000. Okay? Alright, so let's go ahead and plug that in into our calculators. So we're going to have 10, 40 times 24 plus 13000. Answer is 37,960. So it's going to be 37,960. Uh-oh, it looks like there's been a flip here. Account A has actually taken over. So for 24 years, account A is actually gives her more. So for part B, account A will give her a higher return. Okay, so for this one, account A will give her a higher return. Okay, by how much? By how much more will she get? Well, let's calculate what that is going to be, how much more she'll get. It's just a difference, right? So $39,210.69 minus the answer I just got, $1,250.69. So she will get $1,250.69 more using account A. Okay, so there you have it. All right, let's take a look at the next question. So it says JC wants to buy a brand new HD TV. He could buy one now because he has $3,500 to spare, but he thinks that if he waits, the quality of HD TVs will improve. While he waits, his $35,000 earns 4.2 interest annually, compounding continuously in his bank account. The TV he wants to buy costs $1,600 now, but cost increases each year by 6.6%. Okay? This is write a natural Bayes exponential function that gives the value of Jason's account as a function of time. So this is both of actually the increase in Jason's account is continuous. Okay, so let's write an expression for that. Okay, so just to make it real quick, let's do a real quick adjustment to the question. Let's say the cost increases continuously. Okay, sorry about this. So let's say it increases continuously by 6.6%. Okay, per year. All right, so now I can do it. Okay, so part A says write a Bayes exponential function that gives the value of Jason's account as a function of time. Well, since this is an exponential growth that's continuous, we're going to be using the model y equals AE to the RT. Okay, we know the initial amount A. We're talking about Jason's account. How much did he have in his account initially? It's 3,500. What was the growth rate of his account? Is 4.2%. The 4.2% is the same thing as 4.2 over 100. And we will move the decimal point forward twice, both top and bottom. 1, 2, and then 1, 2. It's going to be 0.042. Okay, so that's the growth rate. All right, so we don't know what the time is. The time T is a question mark. or we don't know. So what's the model going to be for for Jason's account? For Jason's account is going to be y equals the initial amount, which is 3,500, e to the growth rate of 0.042 to the t. Okay, so that's the model for Jason's account. All right. Now, how about the cost? Well, we're going to use the same model. Cost is going up also. So what is the initial cost? The initial cost A is 1,600, and the rate that it grows by continuously is 6.6%. We're going to change that to decimal form before we can do any computation. So that's 6.6 over 100. Put the decimal point forward twice, top and bottom, 1, 2. So that's going to give us 0.066. Okay, we have to introduce a 0 here because we moved it 2 places forward. Okay, time t we do not know. So in this case, the model for the cost of television is going to be y equals 1,600 e to the 0.066 t. All right. Okay, now which one? Now let's go to the part C. It says, in how many years will the cost of television exceed the value of money in Jason's account? In other words, how much time does Jason have to decide whether he wants to buy the television? Round your answer to the nearest tenth of a year. So in order to figure that out, it's obvious that the price, the amount of money he has in his account is bigger, right, than the cost, because he has 3,500, but the cost is, he has 3,500, but the cost is 1,600. But you notice that his account is growing at a lower rate than the cost. So eventually the cost is going to catch up and exceed. So when does the cost catch up? When the cost catches up with the amount of money in his account, that's how much time he has. So how do we know when the cost catches up with the amount of money he has in his account? To do that, we're just simply going to equate these two models and solve for t. Okay? So we're just going to equate both of them. I can call this y of the account, and then this is y of the cost. I'm going to set the y of A, which is the amount, the model for his amount, and for the amount of money his account, to y of C, which is the cost. All right, so we're going to set 3,500 e to the 0.042 t equal to the cost, which is 1,600 e to the 0.066 t. Okay? Alright, so to solve this, we need to just get the e's together and the numbers together. So to do that, let's start by dividing both sides by 1,600. So divide this by 1,600. Now divide this by 1,600. This divides out. And this can be reduced. Just divide by zeros here. So we have 35 e to the 0.042 t over 16 equals e to the 0.066 t. Now I need to move this e to the 0.042 t to the left side. So to do that, I'm going to divide both sides by, or I can multiply both sides by 1 over e to the 0.042 t. And in this side, I also multiply by 1 over e to the 0.042 t. Okay? This side divides out. So we're going to have 35 over, we're going to have 35 over 16 equals e to the 0.066 t divided by e to the 0.042 t. Okay, so we can use law of exponents to simplify these. So we have 35 over 16. Using the quotient property of exponents, you just subtract the exponents when you have the same base. So we have e to the 0.066 t minus 0.042 t. Okay, so that becomes 35 over 16 equals e to the, let's have our calculator help us with this. So 0.066 minus 0.042 is 0.024. So it's e to the 0.024t. Now to bring this e down, we have to use a special property of logarithm. So in order to use the property of logarithm, we must take the logarithm of both sides first. So we're going to take the natural logarithm of the left side, 35 over 16, equals the natural logarithm of the right side, e to the 0.024t. Now, what this enables us to do on the right is we can power down, okay? We can power down this exponent. This exponent can be brought down. So we're going to have the natural logarithm of 35 over 16 equals 0.024t times the natural logarithm of e. Alright? Since these are inverses, the natural logarithm of e is just 1. So this is just 1. This comes out to 1. So now to finish this up, we're going to divide both sides by 0.024. Okay, so divide the right side by 0.024 and the left side by 0.024. Okay, this divides out, and then we're going to have t equals the natural logarithm of 35 over 16 divided by 0.024. Okay, alright, we're going to plug that in our calculators. We'll have the natural logarithm of 35 divided by 16, that whole thing divided by 0.024. Okay, to do that, we get 32.6 years. So t equals 32.6 years. So that's how much time he has to decide when to buy the TV. Okay, so there you have it. After 32.6 years, the cost of the TV is going to exceed the amount of money he has in his account. So he's not going to have enough money to buy the TV. He has to borrow money or do something. Okay, so there you have it. Alright, let's move on to the next question. It says the projected worth millions of dollars of a large company is modeled by the equation. Let's write that down. Y equals 241 times 1.04 to the x. The variable x represents the number of years since 1977. What is the projected annual percent of growth, and what should the company be worth in 2001? So this model is consistent with the discrete growth model. Y equals a times 1 plus r to the x, or t. In this case, it uses x. So in order to find the rate, the question is, we know that 1 plus r equals 1.04. So what is r? In order to find what r is, well, first of all, how did I get this equation? Whatever is in the parentheses that we're exponentiating, I set them both equal to each other. Okay? So 1.04 is in the parentheses here. I put that here. And then 1 plus r, I put that over there since they line up. Okay? Let me line them up for you to see so it's obvious. Y equals a times 1 plus r to the x. So I just equated these two quantities in the parentheses. Alright? So to get r, I'll just subtract 1 from both sides. And I can see that r in decimal form is 0.04. So what's 0.04 in percent? 0.04 is the same thing as 4 over 100. Okay? And that is equal to 4%. So we can eliminate option A and C is either D or B or D, right? So what should the amount be in 2001? So from 1997 to 2001 is how many years? So you can count it, 98, 99, 2000, 2001 is 4 years, right? So all we just do is we're going to plug in 4 into our model and calculate what the output is going to be, okay? So the model is y equals 241 times 1.04 to the x, but x in this case is 4 years. So let's plug that into our calculator and see what we get. Okay, so 241 times 1.04 raised to the 4th power is 281.9. Okay, 281.9. So the answer is 281.9 million, right? So the answer is option letter D. So there you have it. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel by clicking up here. More videos can be found on microserve.com. Thanks again, and have a wonderful day.